You can massively boost the capabilities of an LLM by using MCP servers, which tools like Cursor, Claude, and Klein already support. Essentially, anything that has an API, or even anything that can be done by code, can now be done for you by an LLM. Like creating a GitHub issue, reading a GitHub repo, sending a Slack message, updating a database, or even reading Google Maps. This is all powered by MCP servers, so I'm going to show you how you can build your own in minutes. Hey, I haven't made an MCP server to subscribe yet, so you're going to have to click subscribe manually. Let's start out with what is MCP, which stands for Model Context Protocol, and it was actually brought to us by Anthropic. In short, it's an open protocol that standardizes how applications provide context to LLMs, helping you build agents and complex workflows. So say we have our host and client like Claude, and we need to access some external data. Let's make it easy and say the live weather. Well, LLMs are trained on datasets. It can't access that at the moment. So instead, we need to build an MCP server that exposes specific capabilities and tools through the standardized Model Context Protocol. In our case, we would expose that our server has the capability to retrieve the weather. Our server then controls accessing things like the live weather API, or even local files, databases, and much more. The server is then able to send data back to the client to use in its context, so Claude finally knows if it's raining or not. Now that may sound complicated to implement, but it's genuinely only a few lines of code. This is thanks to the SDKs provided by the Model Context Protocol team, all open source. At the moment, they have one for Python, TypeScript, Java, Kotlin, plus on that GitHub, it looks like a Rust one is on its way. I'll be using the TypeScript SDK in this video, but since this is the standard, the concepts I teach will apply in all of the languages, just using the respective SDK. So stick around even if you don't want to choose TypeScript, as we still need to talk about transport, resources, tools, and finally how you add MCP servers to apps like Claude and Cursor. Let's get coding then. Now, since I want to focus on teaching you the MCP server stuff with the SDK, I went ahead and created a template repo, which just gets us started with TypeScript. I'll leave a link to this in the description down below. I've cloned this template into a folder called Better MCP, but essentially all we need is an index.ts as well as a package.json which has the dependencies in it. In this case, it's the Model Context Protocol SDK, as well as Zod, which is something the TypeScript SDK uses for its schemas. And I also have shx down here. This is just a helper for running commands with Node, which sets the file as an executable, which we'll need later when we run this as a command. Let's go ahead and install these dependencies with pnpm. And once that's done, let's head over to the index.ts. As I want to point out the shebang up here, you're going to want to leave this here to ensure that this runs as a command later. You'll see why in a bit. With this example code then, you have everything you need to make powerful MCP servers. So what am I going to build? Well, I thought it'd be cool to create something a bit more realistic than a hello world application. And we here at BetterStack have a radically better observability stack with uptime monitoring, incident management, status pages, log management, and loads more. We also have an API to control some of these though. For me, I'm interested in the monitors API. Monitors are a way of checking whether a service such as a website or application is available. So I want to build an MCP server that uses this API, allowing the LLM to create, delete, and check the status of monitors. Back in the index.ts, I'm actually going to go ahead and delete the example code underneath our server variable, all the way down to where we have transport. We'll be setting that up in this video. Now, our first step is to go ahead and define our MCP server. This is your core interface to the MCP protocol. It handles connection management, protocol compliance, and message routing. This is actually a wrapper around a lower level API, which allows us to define MCP servers in an almost express-like way, making things really simple. There's wrappers like this in some of the other SDKs. For example, the Python one has fast MCP. I'll go ahead and quickly change the name out here from demo. I'll call this something like BetterStack Monitors. Now we're ready to add in features. Let's start with the most common and most powerful then, tools. What are they? Well, tools enable servers to expose executable functionality to clients so that LLMs can interact with external systems, perform computations, and take actions in the real world. Essentially, it's what allows an LLM to run any code that you write. Tools are designed to be model controlled. This means that tools are exposed from the servers to the clients with the intention of the LLM being able to automatically invoke them, or at least ask if it can. I'll be adding a tool to create a monitor, aka send a post request. So now that we have the server defined, creating a tool is super easy. Just call the tool method on server. Now the tool method takes up to 4 arguments. The first argument is always a clear and descriptive name, in my case create_monitor. The second argument is then a description of what the tool does. Now this is optional, but it's very useful to provide a bit more context to the LLM. In my case, I've just said create a monitor for BetterStack. The third argument is also optional, and it's only needed if you want the LLM to pass some parameters to your tool. If you do, in TypeScript, we can use a Zod schema. Since this is odd, we can use things like defaults and optionals, and a useful tip is to provide descriptions with the describe method to help the LLM understand how to fill in each parameter. So in my case, I need a URL and a pronounceable name to create a monitor, so I've said that this is the URL for the monitor, and also it's a human readable name. Now finally, the most important part is the callback function. This is always an async function, and if you need the parameters, they're provided as the first argument. So you can see I can extract the URL and pronounceable name. Now this is where we have our business logic, like running our API calls. All you need to do is return an object with a content array, and content can have a few definitions. The most simple is an object with type of text and a key of text with the content itself. Another choice is image data that's base 64 encoded, and a third option is a resource. We'll look at resources in a bit. The other key the return object can have though is error, name being self-explanatory. This helps the LLM understand that something went wrong and it can go ahead and try and correct it. For my create monitor API call then, I've added in a better stack client. This was actually made by just giving Cursor the documentation. This simply handles making fetch requests with my API key. Back in the index file, I've initialized it with a better stack API key that I'll be getting from an environment variable. Then in the tool's callback function, I simply await the create monitor call, passing in the parameters that we got from our tool, and then I return the response JSON in the text field of our content object with some additional text that says successfully created monitor. I also wrapped this in a try catch, so if something does go wrong, we go ahead and set isError to true on the object, and then in the content we can return some error messages with error creating monitor, and then the error message that comes back from the API. Now we're very close to running our first MCP server. The final thing we need to talk about is transport types. Now there's two types when it comes to MCP, standard IO, aka standard input output. This is what you'll be using most of the time and for anything local running on your machine. SSE is more advanced, it's good when the MCP server is remote. For us then, all we need is standard IO as we'll be running this command on our machine. With those two lines then, we now have a complete MCP server with one tool. The final thing we need to do is go ahead and build this. For that, we can run pnpm run build. Once that's done, your MCP server is complete. You're ready to go ahead and add this to your MCP clients like Cursor and Claude. Now with Cursor, there is a trick to using environment variables, so you need them for your MCP server. Go ahead and follow this step. Otherwise, you can just go ahead and run the command node and then the path to your index.js in the MCP server settings on whichever client that you're using. Since I'm using environment variables though, and I want this to work in Cursor, the trick is to simply create a wrapper script which sets the environment variable. For example, my wrapper script is called better-mcp.sh. In here, I simply set one environment variable, which is the better stack API key, and then I go ahead and run our index.js using node. We also need to make sure that this is executable, so I'll do chmod +x, and then the script. And now all we need to do is open up our Cursor settings, head over to the MCP section, click add new MCP server. Let's give it a name. I'll call this one better MCP. And then make sure the type is set to command if you use standard IO like we did. Otherwise, you can use SSE. Finally, we need the command to run. For me, that's going to be the shell script that I just created. But if you didn't have environment variables, it would simply be node and then the path to your index.js. Let's hit enter on that. And you should see a green dot, which means that everything is up and running and working. And as you can see, we have our tool listed here of create_monitor. So let's try this out. If I open up agent mode with Command I, and then I give this a prompt, create me a monitor for google.com with a name of Google demo and hit enter, after a while of generating, you can see that it says it will create a monitor for google.com using the better stack monitors tool. And as you can see, it's calling the MCP tool, create_monitor, and I can expand this and see the parameters that it's sending to our tool. So it's sending the correct parameters. I can click run tool now, and as you can see, we get the result JSON back of successfully created the monitor, and then the response JSON from the better stack API, and then it's just giving us a bit more information as that's now been loaded into the context. Double checking this on betterstack.com, you can see that we now have a monitor called Google Demo, and if I click into this, I can find out all of the information about my new monitor for google.com. Now let's add our MCP server to Claude Desktop. For Claude Desktop, you don't actually need to do that wrapper script if you have environment variables. Claude Desktop supports them in its config. Let's open up these settings. I'm going to do command, go to developer, edit config, and then it should point you to the Claude_desktop_config.json. Let's open that up in your editor of choice. In here, you're going to want to make your JSON look something like this. We have the MCP servers object, then we have our better stack MCP server. The command is node. The arguments are an array of strings, so we're just passing in the file name here. And then we have our environment variables. Now I have run into an issue with node here where it can't actually find the node instance. To fix that, I have to provide the exact path to node. To find that, you can open up a terminal and type in which node, and then just copy this path here. Then back in the JSON, just switch out the node command for the full path. Save the file and restart Claude Desktop. Once it's opened back up, you should see that we have this little tool icon down here. And if we click on this, it shows that we have our create_monitor tool. So I'll go ahead and ask Claude to create me a monitor for youtube.com. And after a while of thinking, you can see it's creating it right away, and it's asking me to allow the tool run from our BetterStack MCP server, and I'll click allow for this chat, and it's sending it off with the parameter of pronounceable name, YouTube monitor, and then a URL of youtube.com. As you can see, it's successfully created it for me, and it's given me some more information about it that it's got back in that response object. And again, on betterstack.com, we can see that we have that YouTube monitor set up. With Toolsen, you can pretty much do everything that MCP clients and servers are capable of, but there's also resources. These allow servers to expose data and content that can be used as context for LLM interactions. Think file contents, database records, API responses, images, and more. It accepts text content and binary-based 64 data. Now, you might be thinking this sounds similar to tools, but resources are designed to be application controlled, meaning the client application, for example, Claude, can decide how and when they should be used. In the case of Claude, the user has to select the resources themselves, but some clients might load this in automatically. Essentially, they're a get endpoint and shouldn't perform any significant computations or have side effects. If I wanted to fetch my monitors as a resource, since this is a GET request, I would have a few options. The simplest is to define a static resource and return all of the response. The first argument here is the human readable name. The second argument is the resource URI. Now, this doesn't have to exist. We can define our own URI schemes. Next, we provide some metadata to help the LLM understand what the resource is. Finally, we need a read callback function. For a simple static resource, this is just an async function with one argument, the URI, that then returns an object with a contents array filled with our resources. That can have a URI, then it can have text or blob if we're using encoded data, and then a MIME type if known. Now, if I build this and head over to Claude, you can see that a resource is something that I have to choose myself to load in. If I click on this connection icon here, it loads the result of the fetch request into my context. In Cursor, resources just function like tools, where it will ask you if you want to run it. Now, since we have an array of data coming back, we could actually split our response into separate resources with a map. If you do this, each monitor I've set up is loaded like a separate resource in an app like Claude. Another option I would have would be for a dynamic resource. This is where I could use the fetch request to get individual information about each monitor. The setup is similar to a static one. The first argument is always a name, but the second argument should be a resource template. This is going to take in a dynamic resource path and then an object with a list callback. The list callback is how you tell clients what resources they can access through this path. So in my example, I'll load in all of the monitors first and then return them as a list with a name, URI, description, and a MIME type. You don't include any content itself. You can also set this to undefined if you want to let the LLM work out what the URI should be. In the callback, I can then simply call the single monitor API request that I set up, and I can pass it with the monitor ID, which we'll receive based on our dynamic URL, passed in as the second argument of our callback function. Now, when I load resources in Claude, for example, you can see each one is listed individually, so the user can pick a specific one now. Tools and resources seem to be the main supported features at the moment, but there's also prompts. Prompts enable servers to define reusable prompt templates and workflows for clients. For example, if I set one up like this, in Claude you can see I can input the configured arguments and it puts in the rest of the prompt for me. That's everything that I want to cover on MCPs and what is widely supported at the moment. I'm looking forward to features like sampling, where your server will be able to request completions from the LLM, but it doesn't seem to be supported in many clients at the moment. Let me know in the comments below if you set up any powerful workflows with these features, and while you're down there, subscribe, and as always, see you in the next one.